Here we go.
So they want us to figure out if we look at your claim, if the average hospital stay for men is longer than the average hospital stay for women. So your null hypothesis is always that they're the same for these. When you have two populations, means are the same. But alternatively, they're trying to figure out if the men's is bigger than the women's. So the men's longer than the women's, greater than that. So you've got your hypotheses set up. So when you find your critical value, you know because of this that it's greater than, that it's going to be a right-tailed test. Your alpha is 0.01, so you're going to go back to the back of the book, to the Z table, and go all the way down, 0.01, all the way down to Z, and that's going to give you...
Why is it Z again?
Why is it Z? I think... We do need to test because our sample sizes are greater than 30.
Okay.
Good. Yeah. So because n is greater than 30 for both, then you get to go Z all the way down at the bottom of the T table. And when you do that, you're going to get, I think I wrote it down somewhere, 3.75. So 3.75, you know it's positive because it's right-tailed. Because the back of the book, I think, is just going to give you all positives. So it's right here. So it was 0.01, 0.01, two-tailed, all the way down. I grabbed the wrong number. It's a lovely video. Sorry, one-tailed, because I can talk. One-tailed, all the way down, you get 2.33. This was the test stat that was coming later. I'm trying to skip the step. All right, 2.33. Good so far?
Yes.
Awesome. Now we need our critical value, our test stat. I can talk. And you're going to be using, if you have the two populations, it's going to be mean 1 minus mean 2 over the square root of the standard deviation for the first guy squared over his sample size, plus the standard deviation for the second one squared over his sample size. So it's going to be the 5.5 minus the 4.2 all over the square root of 1.2 squared over 32, and then minus the 1.5 squared over the 30. So standard, when you pop that in on a calculator, that's one that you should get 3.75 for.
Okay.
And so now we can make our conclusion, since this guy is way far away from the null, right?
Yeah.
Then it's going to be rejecting that null hypothesis.
Okay.
Now what does that mean for our claim, right? In the beginning, we were trying to claim that the men's score was higher than the women's. And if we're rejecting this one, that means this one's looking good, right? So we say there is sufficient evidence to support our claim.
Okay.
All right? Good?
Yeah.
All right.